A few people have asked me what the next steps are to take after building a BusRaider and which hardware is compatible with that board. So I thought it would be a good idea to do a video and explain some of the hardware that can be used with the BusRaider and how to put it together. To start off with, you need to have built BusRaider and tested it, and there are some videos for different versions of BusRaider. This is a version 2.2 board, and so if you follow the videos, you follow through the testing of the BusRaider and its hardware, then you should end up with a working PCB. At that point, you can plug it into the bus, and actually the testing stages will have involved plugging it into the bus already. This is the Backplane Pro RC2014. This is the sort of minimal black backplane that BusRaider will work with. It has a full row of 40 pins socket on the main bus, and then a kind of half row which involves some of the other signals that BusRaider uses, including bus request and bus acknowledge. So that's the minimum. I can show you some other boards, some other backplanes, or at least one other backplane which will work with BusRaider, which is Stephen Cousins' backplane series. So let's just plug the BusRaider into this board to start off with. We need to choose, I haven't actually populated all of the half rows here, you can probably see, so I have to choose one that I have populated fully. So it goes in this way around. Pin 1 is at the top, and if we line up the pins, and then I find that actually sort of wiggling it in this way, so like this, actually gets it to seat quite well and doesn't bend the pins sideways, which I tend to find a bit of a problem. If you pull the board directly upwards, it often bends the pins one way or the other, and if you push it down that way, you often end up with some of the pins connected and some not. So now if we plug in the HDMI, so this is a mini HDMI connector. I've got a cable which goes from mini HDMI to a regular HDMI that this monitor uses. You can use an adapter instead that goes from the Raspberry Pi Zero mini HDMI to a full-size HDMI, and then use a regular full-size HDMI to HDMI cable. But I find this one's quite useful. It's also got quite a short lead and it's quite thin, so that tends to work quite well for me. So I'll just move that out of the way so that you can see. And then this is a 5-volt power supply. So if I just plug that in, just a final check to make sure I've got everything the right way around. So that's the right way around. Plug it in, some lights come on. There's a red light here on this ESP32 module, which is the Wi-Fi module. And then there's also a green light on the Pi Zero board. And there's, in this particular case, there's a green light on the backplane. So if we now turn the monitor on, then hopefully at this stage we should have the welcome screen. Now, because there's no Z80 hardware at the moment, the screen's blank on this side, so this is where the Z80 programs will be running. But you can see on this side that the Raspberry Pi is showing its credentials. It's version 2.2.061 in this case, and the ESP32 version is also shown on this screen. And we're also connected to the Wi-Fi network. So we've got a Wi-Fi IP address here, 192.168.86.40, which you could type into a browser, and that would immediately bring up the BusRaider's web page, which allows you to download programs and change the clock speed and do various other things. Look at the terminal emulator output, and also to use the PC's keyboard to send characters, so you can use it in serial terminal mode without a separate keyboard. But it also now says in red, keyboard not found. So I'm going to attach the keyboard, and most keyboards come with a regular USB-A connector like this. The Raspberry Pi has these two micro USB connectors. The one on the left is a power connector, I think, and the one in sort of towards the middle is the one that we're looking for to connect this to, but obviously that doesn't go directly into there. So you have to use some sort of adapter, which is called an OTG adapter. This one came with a Samsung smartphone, so that one works perfectly well. There's also these little things you can get on Amazon, and you plug those into the end of the USB cable like this, and then it sort of extends it, and that converts it into a USB, micro USB cable. So I'll plug it in, but you'll probably notice that it doesn't actually do anything, and that's because we have to cycle the power to get it to recognize the keyboard. So I'll do that. And now hopefully when it powers up, we'll find that it's found the keyboard. Okay, that hasn't worked. Not sure quite why that is. I haven't actually tried this particular one before, and it did seem rather difficult to get in, so maybe I will just use the Samsung one, see if that works. Sometimes takes a bit of fiddling around to get these things going. So it actually power cycled itself there. But you can actually see now that the keyboard is now okay. I'll have to take a look at this and see if I can understand why it's not working. But anyway, I've generally used these or little cables that have a USB A connector on the end, which work perfectly well. So the next step is to put the Z80 boards into place. Now I'm using, in this case, I think this is the Z80 CPU 2.1 from Spencer Owen. So this is a very standard Z80 CPU. It just has these 4 pull-up resistors, and as you can see, there's nothing else on the board whatsoever. And it brings out all of the additional pins. The first Z80 board that Spencer produced only had 1 row of pins, so it didn't bring out the bus ACK and the wait signals and other things which BusRaider needs. But this board's perfectly functional, so we're going to plug that one in a moment. And then for memory, I'm actually using this, again, a Spencer Owen 512K ROM, 512K RAM module. And in this case, it's again, there's no modifications to this board. Now this board doesn't support the page operation that BusRaider uses to perform single-step debugging. So with this combination, even though it will run perfectly well, and most of the functions of BusRaider will work, the screen display and so on will work, and the web interface and everything, you can change the clock speed, things like that, you can emulate a serial terminal. This board, since it doesn't support page operation, doesn't allow single-step debugging, but everything else works. So I will unplug the power, and now we'll just plug these boards in. So again, taking care to get them the right way around and all the pins in place. So that's the processor board. So you might notice certain things about this. We're not going to plug a clock in, and we're not going to plug a serial device in, like a 68B50 or an SIO board. So the clock is generated by the Raspberry Pi on BusRaider, and as long as you have this jumper in place, the one that says Z80 clock, then it will produce a clock signal from the Raspberry Pi, which is buffered and then sent down the bus so that it can be used by the processor. And you can also see there's a jumper here for page, which is in place, even though, as I said, it won't actually work with this configuration because this memory board doesn't support it. So, and then the second thing that's missing, you might feel is missing, is the serial hardware. And the reason that's missing is that the BusRaider can emulate a 68B50, so you don't actually need the serial hardware. And I found that a really big convenience, because I find that getting the serial lines to where I want them to be on the backplane is always a bit tricky with jumper lines and so on. However, BusRaider also does support physical 68B50s and SIOs, and you can disable the emulation functionality in the web interface. So we're going to plug. I'll just do that check again, just to make sure everything's in the right place. Looks as though it's okay. Pin 1s are lined up. Plug it in, and then, as you can see, it's running RetroBrew HBIOS directly. So this screen is now your terminal onto the Z80 world, and the keyboard, so you can just type away Z80 commands, and there you have it, a self-contained Z80 computer. So I will probably produce some other videos with different configurations of hardware, because I've been asked by a few people about what's possible, and I'm also in the process of bringing out a Z180 board with its own, which is on a kind of motherboard with its own, with three slots backplane as well, which can also be extended with Stephen Cousins' design. So the reason I've done that is partly because a lot of people have struggled to get the hardware working in the right configuration with standard RC2014 parts, and also the page functionality, which is very important for BusRaider operation, often isn't supported by the boards that are available. So I've decided that would be a good idea, just to simplify things. And you may know that I've also put out a 1 meg RAM-ROM board called BusRaider, which is a kind of version of this board, which I think it was originally a Kislev board, and Spencer did a version of it, and now I've done a version of it which supports the page line and also supports switching from linear to paged mode, which can be very useful if you're trying to use a Z180, for instance, which has an extended address bus. You can run software which requires a linear memory map, and also run with a paged memory map, such as the one required for ROM WBW. And perhaps a final point there is that you can, with that memory board, download all of the firmware from the web page that you need, all of the software, shall we say, for the Z80, directly from over the Wi-Fi from the web interface. So the nice thing about that is that you actually can just have a pure RAM board for 1 megabyte of RAM, which fills the entire address space with linear memory or with paged memory, and then you can just download it as you like using the web interface. So you can download different programs, flip between CPM, ROM WBW, and then go into TRS-80 mode, go into ZX Spectrum mode, and just switch between them freely without actually having to reconfigure any of the hardware. So hopefully that's been helpful, and do give me feedback and let me know if you've got any more questions. Thanks very much.